This is our first episode on the new series, Coordinate Geometry. Now, under Coordinate Geometry, we are going to explore different concepts. The first one being the gradient of a straight line, and then the second one, we are also going to explore concepts like the midpoint of a straight line, whereby you are given the endpoint of the line. We are also going to explore the concept of distance of a line when you are given its endpoint. Moreover, we are going to explore the idea of gradients of two lines when they are parallel, and also explore the relationship of the gradients of two lines when they are perpendicular. And then we are also going to discuss how to find the equation of a straight line given either a point and the gradient, or when you are given 2 points. Let's go straight to it. In this lesson, or rather in this video, we are going to talk about the gradient of a straight line. Now, what is this gradient? Now, gradient, it's nothing but a value that measures. It measures the steepness of a line in relation to the horizontal axis. So that's what the gradient does. It just measures of how steep a line is in relation to the horizontal axis. Now let's draw our Cartesian coordinates so that we can actually view this in line of the Cartesian coordinate. Now this is the vertical axis, which we normally refer to it as the y-axis, and this is the horizontal axis, which we normally refer to it as the x-axis. Then this one, it's the y. So we are going to talk about the gradient of a line in relation to the horizontal axis, which is the x-axis. For example, this line here. Now this line, if we compare it to the x-axis, it's just parallel to it. It's going the same way. It's not steep in relation to the x. So the gradient of this line is 0. So for all horizontal line, the gradient is going to be 0. Now let's try to discuss how we can measure the gradient of a line. Let's say you have, there you go. Now I'll just draw 3 random lines, which we are going to discuss their gradients together. Now we have the 3 lines here. This is our line A, this one is our line B, and this one is our line C. Now our interest is to find the gradient of this line. So in simple terms, the gradient is how many units do I rise for every unit to the right. Let me try to rephrase that. When I'm looking for the gradient, I'm actually interested to the number of units up or down for every unit to the left. Now that's basically the gradient. Now let's go and calculate that. Just by counting the number of squares you go up for every unit to the right. Now let's check this. Now for this line here, line A, I move 1 unit to the right and then go 2 units up. So the gradient of this line, I'm going 1 unit to the left for every 2 units up. So the gradient M is equals to 2 for this line. Now let's check for this one. Now this is 1 unit to the right, and it's the same 1 unit up. How many squares do I cover moving up for every square I move to the left? It's always 1 to the left, then I'm counting the number of squares going up. So for this one, it's 1. So the gradient of this line is 1. Next, Let's check this line. To the right, it's 1 unit. And then going up, how many squares? 1, 2, 3, 4. So this is 4. So the gradient of this line is equals to 4. 4 squares are moved up for every unit to the left. So basically, that's how you can easily see the gradient by just introspection. Now let's look at a principle we can always use to calculate this gradient using an equation. Now our equation is going to require us to have the 2 coordinates on that line. Let's try to formulate that equation. The equation is saying gradient is equals to the rise over run. So that's gradient, rise over run. So basically, what is this thing? Rise, this is actually the change in y. This one is the change in y. The change in x, which is the horizontal axis. Now from there, if you want to calculate a change between 2 points, it's always going to be the final destination, which we can call y2, minus the starting point, which we can call our y1. And this will be over the same thing for x. So it's going to be your x2 minus your x1. And that is the formula we use for calculating our gradient. It's y2 minus y1 over x2 minus x1. So your gradient g, which we normally use m, is equals to your y2 minus your y1 all over the x2 minus x1. That's your formula for calculating gradient. If you want to view at it manually, just remember how we did it. We are saying identify the number of squares you move up for a single square you are moving to the right, or rather horizontally. That means that if you are moving down, it's going to be negative. Now let's look at the special gradients before we even calculate stuff. The first one is the gradient of a horizontal line. If I were to say this is my starting point and this is my ending point, so this is 1 unit to the right, how many units am I going up for this line? That's correct. It's no square is going up, so the gradient of a horizontal line is 0. Now let's look at this line. Maybe let me label this one horizontal line, vertical line. Let's check it. That's our vertical line. Now the question is, for 1 unit square horizontally, in our case, in this line, there's no way we are moving so the line is just vertical. So since there is no way horizontally, there's nothing, there's no unit square going that way or either that way. So basically, there's no gradient for this line. So for a vertical line, the gradient is not there, it's undefined. Now let's check this one. For a line that is increasing, the gradient is going to be positive. And then for a line that is decreasing, the gradient is going to be negative. For your negative gradient, you will have something just like that. Now let's go to the calculations. Let's just throw here. All right, here is our first example. We are given a line together with 2 points. And then you are required to calculate the gradient for this line. Just remember, your gradient is equals to rise over run. And then you are rising along the y. So it's going to be y2 minus y1. Divide by run, you are running along the horizontal axis, x2 minus x1. Please don't mix stuff up here. Some people will have a gradient saying x2 minus x1 on y2 minus y. So to avoid that confusion, always use your rise over run. You are rising along the vertical, so it must be y on top and then your x on the bottom. The next thing we are going to do, we are going to label our points. We have 2 points. One point is going to be 1. The other point is going to be 2. So like that. Then what is our y2? Y, it's this one. And this is 2. Y2, it's 3. So it's 3 minus y1. This one here, it's 0. Over our x2. X is this one. So it's -1 minus. Then this is the other x here, which is x1. -3. And then let's do the math here. So your 3 minus 0 is 3. -1 minus -3, that gives me a +2. So this is 3 over 2, which tells me that the gradient of this line is 1.5. And then even our initial analysis, let's check that. From our initial analysis of finding the gradient, you say you can just pick, say this is the end point. This is 1 unit to the right, and then I'm rising 1 complete square together with a half. That's why the gradient here is 1.5. Next example. Now here is our second example. Then you are required to find the gradient. First things first, you are going to label. Let's label here. Call this one our first coordinate. This one our second coordinate. Why are we doing this one? We don't want to have mixing stuff while substituting into our formula. Once you label like this, you know that this is y2, this is y1, this is x2, this is x1. Just like that. You won't mix stuff. Let's say you didn't label, and then out of curiosity or just calculating in a rush, you say this is your y2, then this is your x2. That's a mix up. Then you will find an incorrect value for your gradient. Now let's go to the formula. Gradient is equals to your y2 minus your y1 over x2 minus x1. Now let's do the substitution here. What is y2? Y2 it's -5 minus y1 it's 3. This is y1, and then this is over what is x2? X2 it's 1 minus -3. And then from there, -5 minus 3, that gives me -8 over 1 minus -3, that is 4. Well, that's 1 plus 3, that gives me a 4. And then this is going to give me a value of -2. This is equals to -2, which is the value for our gradient. Let's try to find the gradient by our previous method. 1 unit, how many units down? 1 unit to the left. How many units down? It's 1, 2, which is 2 units. And then since we are going down, the gradient is a negative. So the gradient for this one is equals to negative. How many units? 2. For every unit you move to the right. How many units are you moving either up or down? That will give you your gradient. Thanks for staying tuned. In this lesson, our next video, we are going to be exploring the concept of gradient of parallel and perpendicular lines. Watch out for our next video.